Namaskar. The story of the periodic table is a fascinating journey that weaves through ancient philosophies, groundbreaking scientific discoveries, and the meticulous work of visionary scientists. Let us have a glimpse of it. The quest to understand the fundamental nature of matter can be traced back to ancient civilizations. In Greece, philosophers like Empedocles and Democritus speculated about the nature of substances. Simultaneously, in India, the ancient Vedic texts described the universe as being composed of 5 elements, known as the Panchabhutas: earth, Prithvi, water, Apas, fire, Agni, air, Vayu, and ether, Akasha. These early ideas laid the philosophical groundwork for the later scientific inquiries into the nature of matter. Fast forward to the 18th century, and we meet Antoine Lavoisier, a French chemist often referred to as the father of modern chemistry. Lavoisier's work in the late 1700s was revolutionary. He defined an element as a substance that cannot be broken down into a simpler substance by chemical means. He also compiled a list of 33 elements known at the time, distinguishing between metals and nonmetals, and helped establish the law of conservation of mass. Lavoisier's systematic approach to studying elements paved the way for future classifications. That time he included calories and fire in his list, which is not considered to be material according to modern science. In the early 1800s, German chemist Johann Döbereiner made a significant observation. He noticed that certain groups of 3 elements, which he called triads, had similar chemical properties, and that the atomic weight of the middle element was roughly the average of the other 2. For example, calcium, strontium, and barium formed such a triad. Although Döbereiner's triads were a small step, they hinted at a larger underlying order among the elements. The next leap came from English chemist John Newlands in 1864. Newlands proposed the law of octaves, suggesting that elements could be arranged in order of increasing atomic weight and that every 8th element had similar properties. While his idea was initially ridiculed, it was a crucial step toward recognizing the periodicity of elements. The most significant breakthrough came from Russian chemist Dmitry Mendeleev in 1869. Mendeleev stated that the properties of elements are a periodic function of their atomic weights. Mendeleev created a periodic table by arranging the 63 known elements in order of increasing atomic weight. Unlike his predecessors, Mendeleev left gaps in his table, predicting the existence and properties of elements yet to be discovered. Based on the location, he could predict the properties of these undiscovered elements. For example, he predicted the element with mass 68 known as EKA aluminium to be the successor of aluminium, which shows similar properties to aluminium. This element would have its oxide formula just like Al2O3 and will be stable in air. Its salt would have a similar formula to that of aluminum salt like AlCl3. His predictions for elements like EKA aluminum, later discovered and named gallium, were confirmed, validating his periodic table. Mendeleev's periodic law states that the properties of elements are a periodic function of their atomic weights. However, this table had some issues. The position of hydrogen was not certain. Also, highly reactive alkali metals and coinage metals were grouped together. Isotopes and lanthanides could not be fitted in his periodic table. In the early 20th century, English physicist Henry Moseley refined the periodic table further. In 1913, Henry Moseley's experiment involved bombarding elements with X-rays and measuring the frequencies of the emitted radiation. He discovered that each element's X-ray frequency correlated with its atomic number, not its atomic weight. Moseley's work led to the modern definition of the periodic law: the properties of elements are a periodic function of their atomic numbers. This led to the reorganization of the periodic table based on atomic numbers, refining the periodic law. Moseley determined that the atomic number, the number of protons in an atom's nucleus, was a more accurate basis for organizing elements than atomic weight. This reorganization resolved inconsistencies in Mendeleev's table and confirmed the correct order of elements. Today, the periodic table has grown to include 118 confirmed elements, with new elements being synthesized in laboratories. The table is a comprehensive map of the matter, categorized into groups and periods that reflect the recurring trends in their properties. The periodic table's evolution from ancient philosophical concepts to a sophisticated scientific tool exemplifies humanity's enduring quest to understand the natural world. It stands as a testament to the collaborative and cumulative nature of scientific progress. This is fast-forwarded history of origin of periodic table. Hope you liked it.